Hello and welcome back to video number 2 in the Learning QGIS video tutorial series brought to you by mangomap.com. In this module, we're going to create a basic map that will be used later as a basis for further demonstrations of QGIS functionality. Working with vector data. Vector data is arguably the most common kind of data that you'll find in the daily use of GIS. It describes geographic data in terms of points that may be connected into lines and polygons. Every object in a vector data set is called a feature and is associated with data that describes that feature. The goal for this lesson is to learn about the structure of vector data and how to load your vector data sets into a map. Viewing layer attributes. It's important to know that the data you'll be working with does not only represent where objects are in space, but it also tells you what those objects are. From the previous exercise, you should have the streets layer loaded onto your map, as you can see here. What you can see right now is merely the position of the roads. To see all of the data available, we need to click on the Open Attribute Table button. It will show you a table with more data about the streets layer. This extra data is called the attribute data. The lines that you can see on the map represent where the streets go, and this is the spatial data. These definitions are commonly used in GIS, so it's essential to remember them. Vector data represents features in terms of points, lines, and polygons on a coordinate plane. And it's usually used to store discrete features like roads or city blocks. Loading vector data from shapefiles. The shapefile is a specific file format that allows you to store GIS data in an associated group of files. Each layer consists of several files with the same name but different file types. Shapefiles are easy to send back and forth, and most GIS software can read them. Refer back to the first video for instructions on how to add vector layers. Okay, so for now, we're going to add the places data set into the map using the same method. Loading vector data from a database. Databases allow you to store a large volume of associated data in one file. You may already be familiar with database management systems, DBMS, such as Microsoft Access. GIS applications can also make use of databases. Database-specific DBMSs such as PostGIS have extra functions because they need to handle spatial data. So now, on the left-hand panel, go ahead and click the Add Spatial Light Database button. If you can't see the button on your screen, check that the Manage Layer toolbars is enabled. Okay, so now that I've clicked the button, we're going to have a new dialog, and inside this dialog, I'm going to press the New button. In the same folder as the other data, I can see that we have the landuse.db file. I'm going to select it and open it. We can now see the first dialog again. Notice that the drop-down select above the 3 buttons now reads land_use.db at, followed by the path of your database file on your computer. Now if I click the Connect button, we'll see that the previously empty box now has 3 layers. We have rural, urban, and water. Now to add those layers to the map, I can either click on them individually or I can do Shift and click to add all 3 at the same time, which is what I'm going to do here. Reordering the layers. The layers in your layers list are drawn on the map in a certain order. The layer at the bottom of the list is drawn first and the layer at the top is drawn last. By changing the order that they are shown in the list, we also change the order that they are drawn in on the map. The order in which the layers have been loaded into the map isn't logical at this stage because we have the roads and we have the places at the bottom and they're actually hidden. So what we're going to do to resolve this, we're going to move the places and the streets layer to the top of the list so they become visible. Now that we've added all of the layers we need from several different sources, what's next? So far we've used the random palette, which has automatically assigned us colors when loading the layers. The current map isn't that easy to read. It would be preferable if we could assign our own choice of colors and symbols, and this is what we're going to learn about in the next lesson. Symbology. The symbology of a layer is its visual appearance on the map. The basic strength of GIS over other ways of representing data with spatial aspects is that with GIS you have a dynamic visual representation of the data you're working with. Therefore, the visual appearance on the map, which depends on the symbology of the individual layers, is very important. The end user of the maps you produce will need to be able to easily see what the map represents. Equally as important, you need to be able to explore the data as you're working with it, and good symbology helps a lot. In other words, having proper symbology is not a luxury or just nice to have. In fact, it's essential for you to use a GIS properly and produce maps and information that people will be able to use. The goal for this lesson, to be able to create any symbology you want from any vector layer. Changing colours. To change a layer's symbology, open its layer properties. Let's begin by changing the colour of the urban layer. If we right-click on the urban layer, we choose Properties, and then inside the dialog, we can choose the Styles tab here on the left. We can change the colour of this layer by clicking on the Colour Layer Picker. So I'm going to choose a grey colour. I'll select black, and I'll choose a grey from the ramp here, and press OK. If we press OK again in the main dialog, we'll now see that the grey colour has now been applied to our map. Changing symbol structure. This is good stuff so far, but there's more to a layer's symbology than just its colour. Next we want to change the colour of the farms, the rural layer. But we also want to eliminate the lines between the different farms so as to make the map less visually cluttered. So let's go ahead and update the colours of the rural layer. I'm going to right click on the rural layer, select Properties, and just like before, first I'm going to change the colour. Let's go for a darker green. I press OK here, and now if I press OK again on the main dialog, we can see the darker green has been applied to the farms. Next we want to remove the lines between the farms. So once again, right click on Rural, go to Properties, and now we're going to choose Simple Fill from the Symbol Layers dialog here, and in one of the items in the form we have Border Style, and from the drop down I'm going to select No Pen, press OK, and we can now see on the map that the lines between the individual farms has been removed. Scale-based visibility. Sometimes you'll find that a layer is not suitable for a given scale. For example, a data set of all the continents may have low detail and may not be very accurate at street level. When that happens, you want to be able to hide the data set at inappropriate scales. In our case, we may decide to hide the streets from view at small scales. To enable scale-based rendering, open the Layer Properties dialog for the Streets view. And then once in Properties, we go to the General tab. Enable scale-based rendering by clicking on the checkbox with Scale-Dependent Visibility. And in the minimum exclusive scale, let's change that down to 1 to 100,000 and press OK. We can now see that the street view has been hidden. The scale bar at the bottom tells us that the current scale is 1 to 110,000 roughly. If we zoom in, the road view is now displayed because the scale is now 1 to 55,000 roughly. Adding symbol layers. Now that you know how to change simple symbology for layers, the next step is to create more complex symbology. QGIS allows you to do this using symbol layers. Let's go back to the rural layer and open up the Style Properties dialog again. At the moment we have one simple fill. We're going to add an additional fill by pressing the plus button here. We can now see that there are two fills in the symbol layer. Now there's a second symbol layer. Being a solid colour, it will of course completely hide the previous kind of symbol. Plus it has a solid line border style which we don't want. Clearly this symbol has to be changed. So let's stop a second and see how it looks with this second symbol colour. So we can now see that all of the farms are blue, and we also now have the lines between the farms which have come back again. Let's go back and change that other symbol. So if I click on it, I'm going to also change it so it has no pen, and I'm going to change the fill style to no brush. We can now see that it's blank on the screen. Instead, let's try changing it to dense 6. As we can see, this has now added dots on top of the green symbol layer. Let's press OK and see how that looks. As we can see, we've now got the green layer, and the green layer has blue dots on top of it. You can add as many style layers as you want in order to build up interesting patterns and interesting colours. Okay, to give you an example of symbol levels, I'm going to change some of the properties on the roads layer. So let's go into the symbol properties again. Just as we did with the rural layer, I'm going to add a second symbol layer. So we now have two symbol layers. For the bottom symbol layer, I'm going to give it black color, and I'm going to change its pen width to 2. Now for the top layer, I'm going to change the color to gray, and I'm going to give it a pen width of nearly 0.5. Okay, that's good. So let's press OK and see how that looks on the map. we can now see that all of the roads have an outline. Now the problem is, as you can see, this doesn't look very good. We can see where all of the different features join, and we can see these little black lines going across the road. So we can fix that with symbol level. So let's go back into the roads properties. And at the bottom here we can see advanced. I'm going to choose symbol levels, and I'm going to click the checkbox to enable symbol levels. Now we can choose that the black outline will be at layer 0 and the grey one will be at level 1. So let's press OK, and let's save that and see what happens. We can see now, and let's zoom in to highlight this, that the black outline is always under the grey line. So we don't have those black lines overlapping the road anymore. Once we've made a symbol layer that we like, we can also save the symbol layer so we can use it again in future. To do that, we go to Properties, and inside the dialog box here we have Save Style. So click on Save Style, choose QGIS Layer Style File, and then we can choose where we'd like to store it on our local system. We'll save it as roads.qml. And now we've saved that symbol style so we can use it again in the future. Symbol layer types. In addition to setting fill colors and using predefined patterns, you can use different symbol layer types entirely. The only type we've been using up to now was the simple fill type. The more advanced symbol layer types allow you to customize your symbols even further. Each type of vector, point, line and polygon has its own set of symbol layer types. First we'll look at the types available for points. So let's go ahead and change the symbol properties for the places layer. So we right click, choose properties, and now if we click on our simple marker here, we have the symbol layer type at the top. I'm going to choose an ellipse marker, and as you can see we've got many settings. So I'm going to change the symbol width, I'm going to change it to a rectangle, I'm going to change the outline width, and I'm going to give it a rotation of 10 degrees. So let's press OK and see how that looks on the map. We can now see that we have our symbols are now very strange looking rectangles with black outlines in them. So let's go back and change those places back to simple symbols. So we click on the ellipse marker again, and we go to simple marker, press OK, and we've now reverted back to a simple marker. In addition, we can also use complex symbols for lines and polygons. Let's go to the roads and see what we can do with roads. So we click on Properties, and if I go to the top symbol layer here, once again in the symbol layer type, I can change it to marker line, and as we can see we can have markers placed on the line. Let's change the interval, press OK, and now we can see that all of the lines have red dots placed on top of them. And we can also do the same for the polygon layer. So we have the grey urban layer here. Let's go into its properties, and for the first symbol layer let's change to a gradient fill, and we can see here that it will fill it with a gradient going from blue to white. Let's press OK and see how that looks. So we can now see that we have a gradient fill. I encourage you to go in and play with all of these symbol style settings. You can do some really interesting things, including importing SVG images and building up symbol layer groups with many different layers to make some really interesting patterns. So in conclusion, changing the symbology for the different layers has transformed a collection of vector files into a legible map. Not only can you see what's happening, it's even nice to look at. So what are we going to do next? Changing symbols for whole layers is useful, but the information contained within each layer is not yet available to someone reading these maps. What are these streets called? Which administrative regions do certain areas belong to? What are the relative surface areas of the farms? All of this information is still hidden. The next lesson will explain how to represent this data on your map.